Hello, Calc. We're watching this on Tuesday, maybe Wednesday, after Tuesday or Wednesday's class. That will be to be announced. We're looking at the derivative of the inverse trig functions. We just have a couple little loose ends to tie up in derivative land, and then we will dive into integral land. So what we're going to do tonight is find the derivative of inverse trig functions. And the one we're going to start with is y equals arc sine of x over a. Remember, another way to write that is sine to the little minus 1, which is also read sine inverse of x over a. Same thing, two different notations. All right, let's remember what that means. So this is saying that there is some angle out there, y, whose sine is x over a. So that's opposite over hypotenuse. So if that's true, let's go ahead and solve for the unknown side, because using Pythagorean we'll see that it's the square root of a squared minus x squared. Alright, that information will help us, and we're trying to find dy dx. Alright, so to do that, let's write what this really means. Like I just said, this means that there is an angle whose sine is x over a. So I'm going to start with that rendition. So the sine of y equals x over a. That's another way to say it. So this is something I can work with, because I can take the derivatives of a sine function. So I'm going to do that from left to right implicitly. So the derivative of sine of y is cosine y dy dx, chain rule. And on this side, this is just a constant, so it's sort of like 1 over a times x, so its derivative is just 1 over a. Now, to solve, we're going to find dy dx by solving. Dy dx equals, we're going to divide both sides by cosine of y. But cosine of y, I can write in terms of x by looking at this equation, or looking at this triangle. What is the cosine of y? It is the adjacent over hypotenuse. So that is going to be equal 1 over a, but when I get here, for cosine of y, I'm going to put in, from my triangle, adjacent over hypotenuse. These a's cancel. So my final expression for dy dx is 1 over the square root of a squared minus x squared. So let's generalize that a little bit. So what I prefer is y equals arc sine of u over a. And y prime then would be the more general form, where u is an expression in x. We would have 1 over a squared, square root, minus u squared, followed by chain rule du dx. So that's what I've developed so far. Alright, I'll erase a little spot here and do one. Alright, what here, we'll say, what if we have y equals the arc sine of 2x? What is y prime? Well, we look at the formula we just developed, and you'll say, well, what is a? This u is the expression in x. So the a is simply, and sometimes we have a number under our expression, and that will show up in our formula. In our case, that number a is just a 1. So when we get to the answer here, it's 1 over a square root. A squared is 1 squared minus u squared. U is this expression in x. I have to square it. And then followed by the derivative of that expression, which is just 2. Alright, clean it up a little bit. we get this. That is the derivative, starting with an inverse trig function, in this case sine, of 2x. It is 2 over the square root of the quantity 1 minus 4x squared. Alright, I'll do another one. There's 6 to do. There's 6 trig functions, so there's 6 inverse trig functions. This is 1. So I'm going to do one more. I'm picking the 2 that are most likely to be on any test. So these arcsine and arctangent. So you got this one down. So let me get rid of it. This time I'll use the other notation, and that will be, I want to do tan inverse. Watch how these are done, because I'm going to assign each of you to do one. Y equals tan inverse of x over a. Same thing as arctan would be. So I'm going to draw the equation out. So it says there's an angle that has a tangent of x over a. Calculating this, I get a squared plus square root of a squared plus x squared. Alright, so with that, I'll go ahead and do what I just did with the sine function, and I'm going to write this in a more meaningful way, and that is tangent of y equals x over a. Alright, so with that, implicit differentiation, secant squared y dy dx equals 1 over a, dy dx equals 1 over a secant squared y. Secant squared on the denominator can be, I'll just leave it there. I could change it to cosine in the numerator, but it's alright where it is. Secant is going to be hypotenuse, a square root of a squared plus x squared. And this is going to be squared over, secant is hypotenuse over adjacent. So what does that simplify to? 1 over a, and then the square root disappears because I've squared it, and this a is squared. So this a will cancel out one of these, and I can multiply the 1 by the reciprocal of this, so the a will just pop up here. Alright, so that is the answer for dy dx, a over a squared plus y x squared. Let's do the more general form. If we have y equals tan inverse of u over a, y prime, so we've graduated from just an x to an expression in x. A is unaffected by that change, but when we get to x, we're going to put in u, and then we'll follow it by du dx. Alright, for the rest of your assignment tonight, I'd like to assign each of you another trig function that you can bring and present tomorrow, and the fourth one we'll do on the board together, or all at once, we'll see. So, we've done sine and tangent. So Morgan, I want you to do arc. I want you to do the same development for the arc cosine. So just set it up just like I did for the sine and tangent, work it through, and come to class with the box that you can present. And see, Joel, you can do, let's see, sine, cosine, and tangent are taken. So let's see if you can do, which one, what other one did I do? Let's see if you can do arc cotangent. And Emma, y equals arc secant of x. And when we come together tomorrow, we'll come up with a missing one, arc cosecant of x. All right, so take the one you've been assigned, work it through, and bring it tomorrow. All right, can't wait to see those. All right, till then, that's it for tonight. I will show you more examples when you do your assignment. Till then, goodbye.